Hello, everybody. Welcome to the virtual workshop of migrating to Amazon DocumentDB. I'm Pratik, one of the senior product managers at DocumentDB. And joining me today is Karthik. Karthik, do you want to go introduce yourself?
Thank you, Pratik. I'm Karthik Tota, and I'm a DocumentDB Specialist Solution Architect based out of London.
Awesome. So Karthik and we're both excited to be here today and walk you through some of the content and demos that we have as to how do you get started migrating to Amazon DocumentDB. So let's dive in. Well, today's agenda covers, what's Amazon DocumentDB, why do you need to be thinking about Amazon DocumentDB, what are migration best practices when migrating to Amazon DocumentDB. Karthik will walk you through migration tools, phases, and approaches, and I'm really excited to go through that session as well. And finally, he has a demo later on where he uses Amazon DMS and DocumentDB to migrate a Mongo-compatible workload to DocumentDB. But let's take a step back and look at AWS broadly. At AWS, our vision is to help you manage all your data, regardless of where it lives. We recognize that you are living in a world that uses some combination of on-premises, one or more clouds, and third parties, and all of it needs to be cataloged and governed, breaking down historic silos. Whether your goal is to replace an aging server, deprecate a data center, or build an application for millions of simultaneous users, we have the approaches that you are looking for. At AWS, our strategy has been to offer the right tool for the right job via choice. This strategy has resonated with customers to date. Top 1,000 AWS customers use tens or more database and analytics services. By working with leaders across all industries and sizes, we have discovered at least 3 core elements of an end-to-end data strategy. First, you need a comprehensive set of services to meet your needs now and in the future. Second, solutions that integrate your data so you can easily access it, no matter where it lives. And third, the right governance strategy so you can free your teams to move faster with their data. So how do you build a modern data strategy? A modern data strategy starts with migrating to the cloud, moving towards infrastructure that enables you to achieve the scale you need at the right cost, while reducing operational burden. Today, AWS customers have the choice of a number of purpose-built database services that suit the precise data model, access patterns, and operational needs. These include Elasticsearch for memory workloads, Neptune for graph databases, and DocumentDB for JSON document workloads. Let's dive in to learn more about DocumentDB. Well, what is Amazon DocumentDB? Amazon DocumentDB is a scalable, highly durable, and fully managed database service for operating mission-critical MongoDB workloads. Let's look at each benefit here more closely. Working backwards from customers' need, we built Amazon DocumentDB with a cloud-native architecture designed for scaling enterprise JSON workloads with ease. Let's look at the first benefit. Amazon DocumentDB is fast and scalable. In DocumentDB, compute and storage are decoupled, allowing each to scale independently. This decoupling enables you to add replicas without putting additional load on the primary. And you can scale out read capacity to millions of requests per second by adding up to 15 low-latency read replicas across 3 AWS availability zones in minutes. DocumentDB's storage system auto-scales storage up to 128 terabyte per cluster. And now, with Amazon DocumentDB Elastic clusters, you can scale to millions of writes and petabytes of storage with little or no downtime or impact to your applications. Second, similar to the AWS purpose-built database services, Amazon DocumentDB is fully managed. So you can scale your database with clicks in the console rather than executing a planned exercise that takes weeks. With a fully managed AWS service, you reduce the administrative overheads required for capacity planning and maintenance while focusing on improving your productivity. DocumentDB is integrated with AWS monitoring services like CloudWatch and CloudTrail, providing you the capability to monitor your workloads. Amazon DocumentDB achieves all of this while also maintaining the high availability, performance, and durability required for modern enterprise applications in the cloud. DocumentDB makes your data durable across 3 AZs within a region by replicating incoming writes 6-way. This ensures your data remains readable in the rare occurrence of a full AZ failure, plus any additional concurrent storage node failures in a different AZ. By replicating new writes 6 ways, DocumentDB is resilient to failures and ensures 0 data loss failovers within a region. And to top it all, you only pay for 1 copy of storage. How cool is that? Amazon DocumentDB global clusters provide disaster recovery from region-wide outages and enables low latency global reads. And finally, on this enterprise-ready section, DocumentDB simplifies security by providing strict network isolation with Amazon Virtual Private Cloud. All data is encrypted at rest with AWS Key Management Services, and encryption in transit is provided by TLS. And finally, because many of our customers with document database needs are familiar with the MongoDB APIs, we designed Amazon DocumentDB to be compatible with Apache 2.0 open source MongoDB APIs. This allows you to migrate your MongoDB compatible workloads to DocumentDB while also using existing drivers and tools with DocumentDB. Karthik is going to deep dive into that later on. Well, if you weren't convinced enough, here are a few other ways our customers benefit from these features. Firstly, they get to focus on innovation. As the service is fully managed, this takes away the administrative activities such as capacity planning, maintenance, and instead, your teams can focus on delivering innovation, business insights, and accelerating your path to market. Secondly, the lower TCO. Because we use consumption-based per second billing and no licensing cost, you pay as you go. Thirdly, our service easily leverages other AWS services. You can integrate with other AWS services with simplified architecture using DocumentDB. For example, DocumentDB integrates with AWS Secrets Manager, which rotates secrets safely, audits and monitors secrets centrally, and removes your ongoing maintenance cost of operating a self-managed secrets management infrastructure. In addition, AWS Backup supports for Amazon DocumentDB allows you to centralize your automated data protection policies across all AWS services. And finally, it's a faster time to market for you. Since Amazon DocumentDB natively stores data in JSON, it's simpler to query and index documents. As we continue to listen to our customers and build new features to meet enterprise needs. Since the 2019 service launch, we have expanded into 18 AWS regions and have launched key features. At reInvent last year, we launched a new feature called Amazon DocumentDB Elastic Clusters that enables customers to elastically scale the native JSON document database to handle over millions of writes per second. This year, we recently added compatibility for MongoDB 5.y protocol, support for client-side field-level encryption, an ODBC BI driver, and many index improvements like parallel indexing and index build progress. Amazon DocumentDB use cases are wide and many, given that document database offers both flexible schemas and extensive query capabilities. The document model works well with use cases that require complex documents that are dynamic and may require ad hoc querying, indexing, and aggregations. For example, when thinking of content management, storing content such as new articles, blogs, recipes, and patient records are a natural fit for document model. In the case of cataloging, we see customers recording outputs of machine learning experiments, inventory descriptions, and pharmaceutical trials, using the flexible, intuitive nature of documents to be able to model, capture, or query that type of content. Thirdly, profile management in gaming is another common use case we see amongst our customers. From collecting game data, storing online profiles, and game management, documents allow you to evolve content seamlessly. Because many mobile applications already use the JSON format, Amazon DocumentDB stores JSON natively, and it makes it easy to store data you're collecting back and forth between devices. In addition, with the scale that AWS and Amazon DocumentDB provides, we are also seeing customers deploy document databases for a much wider range of internet scale use cases, including personalization and IoT solutions. Amazon DocumentDB is being used today by a wide variety of customers, from long-standing global enterprise like Capital One, digital natives like Rappi. In addition, several products like Amazon customers use, such as Fulfillment by Amazon, Experience on Amazon.com, are also powered by DocumentDB. We have customers in virtually every industry, from financial services to retail, from gaming to manufacturing, and many more. We welcome you to explore our customer page when you can hear directly from DocumentDB customers on why they choose DocumentDB and how it has positively impacted their businesses. Well, without further ado, let's dive into how you can now migrate your workloads onto DocumentDB. Karthik, over to you. Take it away.
Thank you, Pratik, for providing us the overview of purpose-built databases and Amazon DocumentDB. I'll start by letting you know why customers are migrating to Amazon DocumentDB, talk about the tools available for migration, the phases involved in the migration, methods available to migrate. Then I'll cover the best practices to follow when migrating to Amazon DocumentDB, and finally see the data migration in action through a demo. Let's look at some of the reasons why customers are migrating to Amazon DocumentDB. As covered by Pratik, Amazon DocumentDB is a purpose-built JSON database serviced and architected to support your operational workload when data is modeled as JSON. JSON provides schema flexibility, and Amazon DocumentDB leverages this flexibility, allowing you to query across any field in the JSON document and index on any field to speed up your reads. Amazon DocumentDB is architected for the cloud and auto-scale storage and IOs, so you don't have to worry about provisioning the EBS volumes or expensive SSDs. We see customers migrating to Amazon DocumentDB from various sources. Most of our customers migrate from other JSON or document databases or MongoDB compatible databases. We do see customers migrating from key value stores as well to leverage full flexibility of JSON model. We also see migrations from Elasticsearch, where customers have more than text search needs and want to do secondary lookups. We'll focus on migration from MongoDB compatible databases for this session. In this section, I'll talk about the tools that can aid in migrating to Amazon DocumentDB. AWS Database Migration Service is a managed migration and replication service that helps you move your database and analytics workloads to AWS quickly, securely, and with minimal downtime and zero data loss. AWS DMS support migration between 20 plus database and analytics engines, including MongoDB or MongoDB compatible databases as the source and Amazon DocumentDB as destination. You can use AWS DMS to perform full load of your data and also replicate ongoing changes in near real time. As Amazon DocumentDB is compatible with MongoDB API, and hence to migrate from a MongoDB compatible database, you can use the native tools MongoDump and MongoRestore to back up from a MongoDB instance and then restore the data onto Amazon DocumentDB. Amazon Document DB integrates with AWS Glue, and customers use AWS Glue to extract and transform the data from their source database and load it to Amazon Document DB. AWS Glue is mostly used while migrating from relational databases to Amazon Document DB. We also have some homegrown tools in our GitHub repository of Amazon Document DB tools to support highly complex migrations. Now, let me focus on the phases that are typically involved in a migration. I recommend customers to go through these 4 phases of migration. I'll also talk about objectives or consideration of each phases as we move on. At a high level, the discovery phase is about figuring out the compatibility. While Amazon Document DB is compatible with MongoDB, there are also differences. Compatibility, we mean that you can use the same tools, drivers, and frameworks that you use with MongoDB to work with Amazon Document DB. Amazon Document DB is built from the ground up as a cloud-native database at AWS and is compatible with MongoDB API. It is not MongoDB under the covers. You can find the functional differences in our documentation. Amazon Document DB has support for majority of MongoDB operators and aggregation stages our customer use. We have customers who were able to lift and shift their workload running on MongoDB compatible databases to Amazon Document DB without code changes. And we also have the customers who had to make some changes to their code base to work around the unsupported operators. We work backwards from the customer needs and build support for more and more operators as we hear from them. We have tools to help you figure out with the compatibility. The next is planning phase, where we focus on how to migrate, which method suits you the best and based on your workload. The next one is the testing, which is the most critical phase. Test your workloads for functionality and performance in lower environment with a workload close to your production. And the final one is the execution phase, where you perform migration based on the options chosen in the planning phase. Our documents covers these stages in a greater depth. Please refer to them at your convenience. And I have added the documentation in the resources slide at the end of this session. Now looking at the objectives of each phase. During the discovery phase, we make sure that application is compatible. Compare database version of MongoDB with DocumentDB. Amazon DocumentDB supports 3.6, 4.0, and 5.0 versions of MongoDB. We have had customers migrating from various MongoDB versions to Amazon DocumentDB 3.6, 4.0, or 5.0. We have customers migrated from very old versions of MongoDB. And we also need to check with the driver compatibility. Generally, the latest versions of MongoDB drivers are compatible with Amazon DocumentDB. And next is to size your instances appropriately. We need to understand your read-write rates and peak and sustained loads. And this would determine the IOPS required for your workload, and Amazon DocumentDB builds for the IOPS. The data characteristics also play an important role in the cost. Some of these are your average document size, current data footprint, and data growth rate. For example, document size have an impact on IOPS cost and storage cost. Backup also contributes to billing, and knowing your RPO, data retention requirements, and how it will drive the cost is important to know before the migration. The final objective in the discovery phase is be informed of migration options available. We will discuss about the migration methods later. Let's move on to the planning phase. In this phase, you determine your Amazon Document DB cluster requirements that is needed during the migration and for regular use. To complete the data migration faster, you can scale up your primary instance during the migration. When migrating MongoDB workload to Document DB, you will be using one of these deployment types, a standalone or a replica set or a sharded cluster of MongoDB. If you are migrating from MongoDB to have minimum downtime migration, oplog is important and you must convert your standalone deployment to a replica set using the rs.initiate command on a Mongo shell. If downtime is applicable, then you don't need to convert the standalone to a replica set and just use Mongo dump and restore. Replica set is the most straightforward and most common deployment and can be migrated using AWS DMS or MongoDB dump and restore. And the next step is you need to choose your migration approach. It could be offline, online, or hybrid, and associate it with a test plan as you wrap up your planning phase. Depending on your deployment type, determine how best to migrate to Amazon Document DB. Oplog helps with minimum downtime migration. It is important to size up your oplog so that it is big enough to hold the data for enough time for your migration. The next phase is the testing phase, the important phase. During the testing phase, ensure that indexes are pre-created. Pre-creating an index on an empty collection will be faster and index updates will happen parallel throughout. Pre-create only the indexes that you use. And size up your oplog. How do you size your oplog? If it takes 5 hours to dump the initial data, then oplog should be twice of that. For sharded MongoDB deployments, ensure that you move individual replica sets in parallel. Turn off the balancer to avoid shard balancing during the migration while migrating sharded cluster data, and this can result in duplicates during the migration. You can run a command to do a cleanup of orphan documents if this must happen. And the final phase is the execution phase. If the three phases are done right, then execution phase will become simpler, where you follow the test plan, track the migration progress, and plan on communicating the planned migration to your stakeholders. Now we have done with the phases. Now let's look at the methods available for migration. The common migration methods are offline, online, and hybrid method. For online and hybrid migration, you will be using AWS DMS or data migration service. Looking at each method in detail. In the offline method, you can use MongoDump and Mongo restores to migrate quickly. This is simple and fast, but it has downtime. If you can withstand downtime, this is the best option due to its simplicity. This method is best for proof of concepts and for the workloads that can offer write downtime during the migration. The prerequisite step is to create an Amazon Document DB cluster and EC2 instance with storage enough to hold the source data and that can connect to the source MongoDB instance and the target MongoDB cluster. Next, your application stops writing to MongoDB. You then perform a MongoDB dump on MongoDB, and the next step is to pre-create indexes in Amazon Document DB, as MongoDB dump and restore doesn't recreate indexes. We recommend customers to pre-create indexes on Amazon Document DB cluster before migrating data. After pre-creating indexes, you can restore the data onto Amazon Document DB and then switch your application to point to Amazon Document DB. If downtime is not an option, then online approach using AWS DMS will help. It is not overly complicated and it helps to minimize the downtime. This is widely used migration method by our customers to migrate from a MongoDB compatible databases to Amazon Document DB. The prerequisite step is to create the necessary infrastructure of Amazon Document DB cluster and EC2 instance that can connect to the source MongoDB and target Amazon Document DB cluster and doesn't need a large storage. And we also require a DMS instance. In this method, the application continues to use MongoDB during the migration, like before pre-create indexes. The next is to create a task with full load and create a DMS task with full load and replicate ongoing changes mode. With this option, DMS perform a full load and then replicates ongoing changes to the target Amazon Document DB cluster. During the ongoing replication, DMS tails the oplog on the MongoDB source and any changes that come to the source are replicated to the target. After replication is caught up, switch the endpoint in your application to point to Amazon Document DB. MongoDB source and Amazon Document DB can set to run in parallel until you are comfortable doing a cutover. Only downtime during the cutover from source MongoDB to the target Amazon Document DB. We will see this online migration in action in the demo. The next method is the hybrid method, which combines offline and online approaches. This is faster than online but requires an additional setup. It has near zero downtime, similar to the online method. The prerequisite step is to create the necessary infrastructure with Amazon Document DB cluster and EC2 instance with storage enough to hold the source data and that can connect to source MongoDB instance and destination Document DB cluster along with your AWS DMS infrastructure. In this method, you use MongoDump to dump the data from MongoDB, and then next you may need to pre-create the indexes and then restore the data onto Document DB using Mongo Restore. Since full load is done using MongoDB dump and restore, you will create the DMS task in replicate ongoing changes mode. With this option, DMS will only replicate ongoing changes since the Mongo dump to the target. Since full load is done using MongoDB dump and restore, you will create a DMS task in replicate ongoing changes mode. With this option, DMS will only replicate ongoing changes. Since the Mongo dump to the target Amazon Document DB cluster. During the ongoing replication, DMS tails the op log on the MongoDB source, and any changes that come into the source are replicated to the target. After the replication is caught up, switch the endpoint in your application to point to Amazon Document DB. MongoDB source and Amazon Document DB can set to run in parallel until you are comfortable to do a cutover, and only downtime is during the cutover from the source MongoDB to the target Document DB. Now let's talk about some of the best practices for the migration. I'd like to start the best practices with some homegrown tools that my team, the specialist solution architects, have built to help customers. These tools are not officially supported by AWS. To help with operator compatibility, we have put together a tool that will pass your Mongo logs or your application source code and let you know if there are any operators that are not compatible with Amazon Document DB. We'll show you how it can be used in this demo. To help with index compatibility assessment, we have another tool that passes your indexes in MongoDB and provides the information on incompatible indexes, if any. This tool also provides an option to pre-create the indexes in Amazon Document DB, and we'll be using this tool also in our demo. It is important to size your op log to capture all the changes during the migration. To understand how many write operations are stored in MongoDB oplog, we have a tool that reads the entire oplog and produces the log file containing the counters for insert, update, delete operations by the collection. To help with the sizing and pricing, we have a calculator that accepts the data characteristics as inputs and provides sizing and pricing information for your workload as output. Also, to speed up your migration, you can scale your primary instance in Amazon Document DB and then scale it back. This will give you more compute to process your additional writes. If you are using MongoDB dump and restore, you can set the num insertion workers per collection to match the vCPUs on your Amazon Document DB primary instances. This will speed up your migration by leveraging the parallel execution of threads to restore the data. And it is very important to remove unused indexes and data before migrating to Amazon Document DB. Lastly, testing is not optional. It is very important to test your workload with the workload close to your production. Now let's see the data migration in action. Now I'll demonstrate migrating from a MongoDB compatible database using the online method. I'll be using a MongoDB replica set as my source, and here it is my 3-node MongoDB replica set. I will now connect this to this replica set via Mongo Shell using AWS Cloud9, which is a browser-based IDE, and show you the user info database and the collection I'm interested in migrating. So I have only one user database in my cluster. Let me switch to that user database and let me show you the collections in this. I have two collections, and these two collections are constantly uh, getting new records inserted. Our first step is to check with the compatibility. So I will be using the compatibility check tool from Amazon Document DB tools to get a report on the usage of any unsupported operators in my workload. The compatibility check tool can scan MongoDB log files or the code base to identify the MongoDB operators used by the application. So I copied the log files, MongoDB log files to this AWS Cloud9. And here are my MongoDB logs from the 3 instances. Now I'll run this Amazon Document DB toolkit with the compatibility tool, and I provide the log folder as an input. You should set the MongoDB logging to verbose mode to capture all queries related to your workload in the logs. So the compatibility tool ran and it has provided me the report, and there are no unsupported operators used. I'm good with the operators. The next step is to check the index compatibility. For this, I would be using the index tool from the toolkit, and this tool needs to dump the index to run the checks. So let us download the indexes by providing the dump index option to the tool. This is my command. I'm providing the dump indexes options and the directory to dump the indexes. Now this index tool has dumped the indexes into my dump directory. Let me show you. And we have the user info database. And here are the index details for my both of the collections. Now I need to check the compatibility by running the tool with the show issues options. The output tells me that I have an index that is not supported, which is the text index. Text indexes are not supported in Amazon Document DB. To run a full text search on JSON data, I can use Amazon Open Search Service integrated with Amazon Document DB. And as the compatibility is sorted, next is the planning phase. I need a target Amazon Document DB cluster, and here is my 3-node Amazon Document DB 5.0 cluster. It's a getting started with Amazon Document DB is my cluster name. And as I'm doing an online migration using AWS DMS, I need a replication instance for DMS. And here is my DMS migration service, and I have created one replication instance here for this migration. And I need an EC2 instance that can connect to the source MongoDB and the target document DB. For that, I'll be using the same AWS Cloud9 which I used earlier. Now I'll connect my to target Amazon Document DB cluster to check the connectivity and see if it contains any data. So it's an empty cluster. Now I'll start migration by pre-creating the index as it is a best practice using the same index tool. Let me exit. Now I'll be providing the index tool with different options. I'll be providing the skip incompatible index, and I'll also mention the restore index options for the index tool. And now I ran this and it has created the index on Amazon Document DB. Let's go and see what are the things it has created. So it has created two collections, user orders and user profiles. Let me quickly show the index on one of the collections. It has created the indexes on this collection, barring the incompatible indexes. And as the indexes are created, my next logical step is to start the data migration using DMS. Moving on to DMS console. For DMS to start migrating the data, I need to configure a DMS task with the source and target endpoints along with the selection rules mentioning the objects that are to be migrated. Now I'll create a source endpoint with the engine as MongoDB. I'll move on to endpoints and choose endpoints and create endpoint, and I'll mention it as source endpoint and give a name for the endpoint, source. It's an optional field. Source engine. For the source engine, I'll choose MongoDB. And I choose to provide access information manually. And for Mongo IP, I provide one of my replica set IP, which is 10.0.0.50. And the port would be 27017. And authentication mode, I choose password, the username, and the password for my MongoDB. And for the database name, I provide users info, which is the database I would be using. Leave the remaining options to default and navigate to the test endpoint connection and choose the right VPC and replication instance and run the test. And test the connection for success. It takes a minute for the test to complete. Yep, it is successful. And now I choose to create endpoint. And I need to do an additional step before I move on to creating a target endpoint. I choose the endpoint I created and I move on to schemas, and I want to refresh schemas in this using the replication instance. It takes another minute to populate the schemas. You should see user info or the database you mentioned here. Yep, I have my users info here. So I'm good with the source endpoint creation. Now I'll create the target endpoint. I move on to create endpoint, and now I choose a target endpoint and I provide the endpoint identifier with some unique name. And for engine, I choose as Amazon Document DB with MongoDB compatibility. And here also I provide the access information manually. And for the server name, I provide Amazon Document DB cluster endpoint. I come to the Amazon Document DB console and choose the cluster and choose a configuration, and I get the cluster endpoint here. I copy the endpoint and I use it as my server name, and I'll be using the port as 27017, and for the username I would be using lab user. And my Amazon Document DB cluster is SSL enabled. Amazon Document DB cluster enforces best practices at the time of creation, like encryption at rest and encryption is transit is by default enabled. You can turn off them. For my current cluster, my SSL is enabled. So I choose verify full and I provide the certificate. You see the Amazon Document DB certificate in the connection string or the connectivity and security tab. This is the SSL certificate I'm using. I download it onto your local and provide it for the CS certificate details. Click on add CS certificate and I choose the file. This is the global bundle given name, import certificate, and the database name is users info, the same database. So my test is successful. I can choose to create endpoint, and I have two endpoints. Now I create a migration task utilizing these endpoints. So I move on to database migration task and choose create database migration task, and I provide a unique identifier, MongoDB to document DB, and choose the replication instance. I only have one, and the database source endpoint MongoDB source, target endpoint document DB target. And coming to the migration type, I choose migrate existing data and replicate ongoing changes. Let me tell you at this juncture, DMS offers three types of migrations. The first one is to migrate the existing data. If you can afford or take an outage for the duration of the full load, you can choose this option. Migrating with this option is simple and straightforward. This is equivalent to taking a backup of the source and restoring it onto the target. The next mode is migrate existing data and replicate ongoing changes. With this option, AWS DMS captures changes while migrating your existing data, and AWS DMS continuously capture and apply the changes even after the bulk data has been loaded. Eventually, the source and target databases will be in sync, allowing for minimal downtime during the migration. And the third one is replicate ongoing changes or replicate data changes. In some cases, you will restore bulk data using method outside of DMS, and you want to use the DMS to only the apply changes that happened onto the source to the target since the bulk load. In our case, the hybrid method uses this mode as the bulk data is loaded using tools outside DMS, and we want to replicate the changes that have happened on the source since the backup. So as we migrate the data using online method, we chose the second one, migrate the existing data and replicate ongoing changes. And on the task settings, I chose target preparation mode as do nothing because we have created the indexes and collections on our target database. And I'll turn on CloudWatch logs. And on the table mapping, I will add a new selection rule to choose the schema to migrate. I don't want to migrate the system databases in my MongoDB like local, admin, and test database. I only want to migrate user info database. So I choose schema as user info database. and I choose automatically start migration task on create, so that once the task is created, the task will also start running. I click on create task and it takes a minute for to create and start running. Let's give it some time. Now the DMS task I created is in running mode. Let's explore this and move on to the table statistics. We see the total statistics of this table that is happening, what is the full load and what is the total rows it copied. So it means that migration is running and the data copying is in process. Let's log into our source and target databases and see. Now let's connect to MongoDB source and DocumentDB target using Mongo shell from the Cloud9 to see the actual data if it is migrated. So left side is my source and right side is my target. And this is my MongoDB and this is my DocumentDB. Show DBS. I have, as it is MongoDB, I have the system databases. Let me switch the database to user info. And let me show you here on the right. So the user orders has 25672 on the source and 25676 on the target. And let's see, 25769 and 25769 or 25. So the replication is catching up. Let's look at the another collection, user profile dot count on the source, db dot user profile dot count on the target. It's almost the same. We have 205544, 20545. So the replication is caught up on the user profiles as well as on user orders. So it means our data is in sync now. So at a particular point time, you can do a cutover from source to destination. So this is, and you can also monitor the progress of replication from the table statistics and CloudWatch metrics. Here you can see, you can refresh the data and it will show you how much time it took and what are the total number of rows it has migrated from the AWS DMS metrics. So that's all I want to show you in the demo. We have migrated the data from MongoDB source to DocumentDB destination, and you can do a cutover whenever you want. Once you are comfortable, that's all. Thank you. Now we have seen the demo. Now you can start Amazon DocumentDB for free if you haven't used it in your AWS account. You can get 750 hours per month of T3 medium instance, 30 million IOs, 5 GB of storage, and 5 GB of backup for 30 days. Once 1 month free trial expires, you or your usage exceeds the free allowance, you can shut down your cluster to avoid any charges or keep it running at our standard on-demand rates. Here are some resources that I was referring to during the session: the migration guide and Amazon DocumentDB toolkit. I hope the session provided you good insights on migrating to Amazon DocumentDB. I want to thank you for your time and attention.